Hello everybody, and welcome to part 3 of our video series on the parabola. We're going to do some more examples here, and let's start with this example. Find the standard equation of the parabola that satisfies the given conditions. Also find the focal diameter. So the conditions in this case that are given are the vertex, which is 1, 1, and the directrix, which is x equals -2. So I'm going to start by graphing that information. So our vertex is here, and our directrix is at x equals -2. And remember, our graph for our parabola always faces away from the directrix towards the focus, so that tells us the graph is going this way. So if we have a right-facing graph, that tells us we're going to have y squared, but in this case it's shifted, so y minus k squared equals, and since it's facing right, which is the positive direction, we'll have a positive 4p times x minus h. Now, the vertex, as always, is a distance of p away from our directrix, which in this case is x equals -2. So from x equals -2 to 1, that's 1 minus -2, that's 3. So our distance for p is 3. And we can plug that right into our equation, and we get y minus 1 squared equals 4 times 3 times x minus 1. In other words, y minus 1 squared equals 12 times x minus 1. And the focal diameter here is just 4 times p, which is 12. All right, well that's it for example number 5. Let's take a look at another example. Find the standard equation of the parabola that satisfies the given conditions and find the focal diameter. As always, we're going to just graph these conditions and figure out what this thing looks like. Okay, so our vertex is at 0, 1. That's right here. Our focus is at 0, 2. That tells us our graph is pointing up towards the focus from the vertex. And it also tells us that our distance between the vertex and the focus, which is p, is equal to 1. Now, since this is a graph facing up, we're going to get an x squared equation, so that's x minus h squared, and it's up, so it's positive, 4p times y minus k. In this case, h and k is 0 and 1 respectively, so we get x minus 0 squared equals 4 times 1 for p times y minus 1. In other words, x squared equals 4 times y minus 1. And our focal diameter is 4 times p, which is just 4 in this case. All right, moving on. Here we're given a graph and asked to find the vertex, the focus, and the directrix of the parabola. So in this case, we're going to have h equals 3, so our vertex. That's going to be 3 and -2. We get the opposite of what we had for y here. All right, so we get 3, -2 for our vertex. And what do we get for p? Well, 8 here is going to be equal to 4p. So p equals 2. So that gives us 2 key pieces of information. And we have one more key piece of information, which is that this is a y-squared equation. Y squared tells us it's either right or left. And since our right-hand side is positive, that tells us this is a right-facing equation. So this faces right. All right, well, we can begin to graph this information now. Let's first plot our vertex. That's going to be at 3, -2. And now we're facing right, so we're going to go at a distance of p. Actually, I'm going to need to move my little vertex notation here, just to make things easier. So we're going to go at a distance of p to plot our focus. And since we're facing right, we're going to go towards the right for our focus. And p is 2, so that puts our focus right here at 5, -2. And our directrix is going to go left by a distance of 2. So that puts us here at x equals, not negative, x equals +1. And let's go ahead and graph this thing. So we've got our graph, and let's go ahead and list the remaining information here. Our focus is at 5, -2. And our directrix is the line x equals 1. And that's it for example number 7. All right, so one of the important properties that comes up in parabolas is something called the reflecting property. Now, this is a property of the geometry of the parabola, and it says that any ray projecting from the focus of a parabola will be reflected back in the direction that the parabola opens. And we mean reflected exactly back, straight forward. So if you've got this point, the focus, and you shoot a ray this way towards this parabola, then it's going to bounce straight outwards. And this is why flashlights are designed the way they are designed. The flashlight's bulb is placed at the focus, and the light reflects from the mirrored backing that's in a parabolic shape so that more of the light is focused straight forward and you get a more efficient working flashlight. So let's take this property and use it on this problem. So a parabolic flashlight reflector is to be 4 inches across at its rim and 2 inches deep from the vertex to the plane of the rim. Where should the bulb be placed? So the sensible thing to do here is to make our work as easy as possible and to center or place the vertex at 0, 0, facing up. We'll give ourselves the easiest version of the equation that we can. So it's 4 inches across the rim and 2 inches deep. So that means that at the peak here, this point is going to be 2, 2. And this point is going to be -2, 2. And that's because the total distance across should be 4. So that's 2 in each direction. and the depth is also 2. So if we want to find where this light bulb should be placed, we need to determine where the focus would be. So the first thing we're going to do is write our general equation. So this is an up-facing parabola centered 0, 0. So this should have the form x squared equals 4py. And if we want to solve for p, all we need to do is plug in an x and y value that we know is on the graph. And in this case, we know that 2, 2 is on the graph. So that implies 2 squared, which is 4, equals 4p times 2. In other words, 4 equals 8 times p. And therefore p is 1/2. So that tells us that the focus is going to be 1/2 of an inch above the vertex, which is 0, 1/2. So we could describe that in a couple different ways. We can either describe the point in terms of the graph we have, or we can say it's 1/2 of an inch above the vertex. All right, well, that's it for that example. Now, I want to take a look at one more topic here, which is recognizing what would be called the general equation of a parabola. So the general equation of the parabola looks like ax squared plus cy squared plus dx plus ey plus f equals 0. Under the condition that a times c equals 0 and either a or c is not 0. In other words, one of the two, a or c, is 0. So to make that hopefully a bit more clear here, a parabola only has either x squared or y squared. So one of these needs to be 0. It could be the c, or it could be the a, but not both of them. So if either of those was true, then you would get an equation for a parabola. Now, if we have an equation for a parabola in this form, it might be a little bit tougher to actually find our standard equation, graph it, etc. So we have to do a little bit more work. Let's take a look at an example of that. Find the vertex, focus, directrix, and axis of the parabola, x squared minus 8x plus 2y plus 4. So in this case, we're going to have to do what's known as completing the square, because we want to put it in the form. Since we have x squared here, we're going to want to end up with x minus h squared equals 4py minus k. And that means I'm going to have to go through and see how I can manipulate this equation to do that. Well, the first thing I'm going to do is rewrite this slightly. That's x squared minus 8x, and I'm going to leave 2 gaps here. Plus 2y plus 4 equals 0. And what we're going to do is complete the square by adding and subtracting appropriate values here. And the idea behind completing the square is actually very simple. If we have a general parabola that looks like x squared plus bx plus b over 2 squared, when we factor this, we would get x plus b over 2 times x plus b over 2, or x plus b over 2 squared. Similarly, if we had x squared minus bx plus b over 2 squared, we would get x minus b over 2 squared. So it's just noticing that this type of quadratic always factors to x minus b over 2 squared, and the first one factors to x plus b over 2 squared. So what we're going to do is look at our value for b here, which was 8. We're going to divide it by 2, and we're going to square it. So plus 8 over 2 squared. But if we add it, we need to not actually change the value of the equation, so we have to subtract the same thing. right? Altogether, what have we done? We've added 0. We haven't changed the equation at all, but what we have done is changed how the equation is written. So this gives me x squared minus 8x plus 4 squared, that's 16, minus 16 plus 2y plus 4. Now, be careful not to make the mistake to add this out, because the whole purpose here was that now this trinomial that we have, x squared minus 8x plus 16, can be factored into x minus 4 squared. And then what do we have left here? We have plus 2y minus 12. Now, in order to get this into the proper form, I need to take all of my terms except for x minus h squared, and I need to move them to the right-hand side. So all of this needs to go over here. So that gives me x minus 4 squared equals negative 2y plus 12. And now, in order to get this in the form 4p times y minus k, I'm just going to factor out my negative 2. And now I can get all of the information that I need from this standard equation. So we've moved from the general equation to the standard form, and our vertex is immediately clear. We've got x minus 4 and y minus 6, so our vertex is 4, 6. Now 4p should be equal to 2, which tells us that p is 1/2. And in order to avoid making any mistakes, we'll go ahead and graph what we have so far. We see that since this is x squared, and we have a negative on the right-hand side, this is a downward parabola. And our vertex is 4, 6, so 1, 2, 3, 4, 1, 2, 3, 4, 5, and 6. And let's just plot that right here. And since p is 1/2, well, my scale doesn't do me any favors here, but I think we can get the idea. Since our graph is facing down, that puts puts our focus right here at, one moment here. So our vertex was 4, 6. So our focus is shifted down by 1/2. So our focus would be 4 and 5.5, or in other words, 11/2. And our directrix should be right above. And we've gone up just slightly by 1/2. So this should be y equals 6.5, or in other words, 13/2. So that's our directrix. This is our focus. And the question also asks for the axis of the parabola. That's just the line that's passing through the vertex, the vertical line passing through the vertex here. So the axis of the parabola is just x equals 4. All right, I believe that's everything that was asked for. Great. All right, well, that's it for that example, and that's it for our series on the parabola. I hope this was helpful. Thank you for watching.